All right, welcome back. In this video, I want to talk about the scientific method briefly, and then basic research methods in psychology. Now, if you've taken other science classes before, you've probably heard a lot of this already, and that's great. You're probably already an expert. That's outstanding. But in any science class, you have to brush up on these basic tenets. So first and foremost, I guess I want to ask the question, why do we even need psychology? Isn't psychology common sense? And I think one of the things we need to talk about is hindsight bias. Hindsight bias is the tendency to assume you knew something after you found out that information. So let me give you an example. Here, this is it's a description of a psychological study. It's a random study that I want to use to demonstrate the idea of hindsight bias. So the title is Territorial Defense in Parking Lots. And what these researchers wanted to do was to measure the amount of time it takes for people to exit a parking space, whether or not somebody is waiting for that parking space or not. In other words, do people take more time or less time to exit a parking space if somebody is waiting for them? And so let's look at both sides of the argument. Imagine you find out that the results of this study were people took less time to exit a parking spot if somebody is waiting for them compared to if nobody is waiting for them. Well, you might say that makes perfect sense. People want to be courteous. People want to be respectful of other people. And so if somebody's waiting for me, if I'm reversing out of a parking spot, I'm going to hurry up so that I can help other people and the world is a good place, so on and so forth. But on the other hand, imagine that the results of this study were the complete opposite. Imagine the results of the study were that people took longer to exit if somebody was waiting for them as opposed to if nobody was waiting for them. Again, you might be able to rationalize that very easily. You might say, well, that makes sense because if somebody's waiting for you, maybe you need to be extra careful so you don't run into them while you're exiting your parking spot. Or maybe even you want to make somebody wait because it's a little bit of a, it's a power thing. You have the opportunity to exert power over somebody else. But the point is that no matter what the results of this study were, you were probably able to rationalize it and make sense of those results. And that's hindsight bias. We don't want to always rely on our intuition or assumptions because many times our assumptions are wrong. And that's why we need research. And so, you can actually read the results of this study. They basically found that people took longer to leave if somebody was waiting for their parking spot. So we need the scientific method. We need psychology because sometimes our intuition is wrong. And so we have to be using critical thinking as opposed to opinions and assumptions about the world. So what does that mean? Well, what it means is we use the scientific method. And the scientific method is something that you should be reading all about in the textbook. But basically, the scientific method is it's a systematic approach to gathering evidence. And that's it. It's all about developing hypotheses, testing those hypotheses, and gathering evidence. So, in other words, we want to make decisions based on reliable information. And that does not mean that the scientific method is, it always gives us the right answer, but it allows us to make more informed decisions. So definitely read more about that in the textbook. But again, right now I want to cover basically the three major ways that psychologists and other scientists use the scientific method. So here are the three basic research methods in psychology. And the first is description. So descriptive research is the starting point for any science. This is where you want to begin when you don't really know something about a question that you're interested in. So description is easy. It's literally just making observations, writing down things that you notice about the world. So for example, a case study. A case study is basically it's an in-depth analysis of one person or one group, so that you get really detailed information about some phenomenon. The problem with a case study is you don't necessarily know if the information you're gathering applies to other situations. And so maybe correlations and experiments might be better, but description is an outstanding place to begin. So for example, if I wanted to know about aggressive behavior, description might simply be just observing people and trying to make note of how much aggression they display or when they display aggression. An important aspect of description is naturalistic observation. And the reason this is important is because it allows us to avoid the Hawthorne effect. So I'll come back to this in 1 second, but what is naturalistic observation? This is where you describe people or animals in their natural habitat. And the reason for that is this is the best way to get valid and reliable information. So specifically, in a naturalistic observation, the research participant or the subject is unaware that they are being observed. And somebody who is very famous for naturalistic observation is Jane Goodall. She is an ethnographer who famously studied primates, and we have learned a lot about primate behavior through Jane Goodall's research. And basically what she did was basically camouflaged herself. She would hide herself so that these animals would act naturally. Because essentially if research participants or subjects are aware that they're being watched, they might act unnaturally, and therefore the measurements that we take might not necessarily be reliable. So a famous example comes about in what's known as the Hawthorne effect. And essentially, the way that I think about this example is that there was a researcher who was hired by a factory owner in order to make the factory more productive. And so he has a hypothesis. His hypothesis is, I'm going to turn the lighting up, make the factory brighter. And if the factory is brighter, maybe that will change the productivity of the workers. So the researcher, he brightens up the factory, and what he notices is that the workers do get more productive. So he says, this is great. I now can go to the factory owner and say, make sure the factory is bright and the workers will be more productive. But in order to gather more proof, he goes back to the factory and turns the lighting down. I don't know if you can see that. I'm trying to turn the lighting down here. But he expected the factory workers to get less productive when the room was not as bright. But when he turned the lighting down, the workers got more productive again. And so now the researcher was confused. He turned the lighting up and they got productive. Turned the lighting down and they still became more productive. So of course what happened here is what's now known as the Hawthorne effect. And this is the idea that individuals modify their behavior when they know they're being watched. And so they weren't acting any differently because of the lighting. They were simply acting more productive because they knew they were being observed. And so that's a problem because in psychological research, we want to study human thought and behavior in a reliable and valid way. So it's always important, whenever possible, to study people and animals in their natural habitat. All right, but the problem with descriptive research is it doesn't really allow you to look at relationships between two variables or more than two variables. And so in that case, you want to move on to correlational or experimental research. And each of these has their pros and cons. So let's talk about them. A correlational study is where you measure two variables in order to see if there's a relationship between them. However, correlation does not equal causation. This is very important. So let's look at an example. If I go to this graph here, what we see here is a correlation between the amount of crime in a city and the number of churches in a city. And what we see here is that there is a positive relationship. Basically, what this graph is telling us is that in cities where there are more churches, there's also more crime. So there's a pattern here, and that's all we get with a correlational study. We cannot go beyond that because what's tempting here is to assume that one of these variables is causing a change in the other variable. For example, are churches causing crime? Because when there are more churches in a city, there's more crime. But that doesn't really make sense. So maybe it's the other way around. Is crime causing churches? Maybe when people commit a bunch of crimes, they want to go to church or something like that. But what we're seeing here is a famous example of the third variable problem. The third variable problem is where some extra variable, some third variable, is actually to blame for the relationship between these two variables. So these two variables, crime and churches, are actually not causing one another. They are completely caused by a third variable, population. And we're not measuring population here, but if we were, we would see that cities with larger populations have more churches because there's more of a demand, and cities with larger populations also have more crime. So that's the problem with the correlational study. You look at two variables, you simply measure each one to see if there's a pattern, but you cannot necessarily say that one is causing the other. So if I want to know about cause and effect, I need an experimental study. It's the only research method that allows the researcher to determine cause and effect. And we'll talk about how you do that. So basically you do that through what's known as manipulation. Manipulation means, let's talk about a basic experiment. In a basic experiment, you would have two groups, and one group gets treated in one way, and a second group gets treated differently. That's what we mean by a manipulation. The variable that is manipulated is called the independent variable. So let's look at a new example. Let's say, does alcohol cause aggressive behavior? So imagine I want to know, does alcohol cause aggression? I would have two groups. Group A drinks alcohol, and Group B does not drink alcohol. If there's a difference in aggressive behavior, I now have some evidence to suggest that alcohol is a causal influence on aggressive behavior. So experiments are the gold standard because they're the only method that allows one to talk about cause and effect. If they're the gold standard, and correlations can never talk about causal relationships, why would I ever do a why would I ever do a correlational study? And there's a couple reasons for that. The first reason is that correlational studies are easier to conduct. All they require is measurement. So I don't have to do any manipulation. Correlations are often quicker, they're more efficient in terms of time and money. The second important reason is that correlations, an experiment cannot always be conducted for ethical reasons. So for example, what if I wanted to know, does homelessness cause mental disorder? That's an important question for our society. But in order for me to test that in an experiment, I would have to manipulate homelessness. I'd have to have two groups of people, and I'd have to ask the first group to become homeless and the second group to not become homeless. And you can probably see that there are some ethical concerns there. So I'm probably not going to be able to explain or investigate homelessness with an experiment. But I can rely on correlational data. So specifically, I can measure the amount of mental disorder in the homeless population compared to the non-homeless population and see if there's a pattern. But just because there's a pattern does not mean I can extrapolate beyond that. So let's go back to our graph here and look at one more example. So we already looked at this example. I'm going to just change this briefly and look at ice cream sales. And I'm going to keep this the same, crime. There's also a positive relationship between crime and ice cream sales, specifically on days of the year where more ice cream is sold, there's also more crime. Now, what's going on here? Is ice cream causing people to act, very strangely and commit crimes? It's possible. Sugar is a dangerous thing sometimes. Probably not that likely, though. So what about the opposite? Is crime causing ice cream sales? Again, I guess that's possible. Maybe after a long day of committing crime, you feel like you need to go out and get some ice cream to reward yourself. But again, probably not that likely. So there's that third variable. And this one, it's heat or temperature. Specifically on days where it is hotter, more ice cream is sold and more crime occurs. So just because there is a correlation between crime and ice cream sales does not imply that one is causing the other. If I want to know about causal relationships, I have to use an experiment. So for example, I might have two groups, give one group ice cream, give the other group no ice cream, and see if there's a relationship or a cause and effect when it comes to ice cream and crime. And there probably won't be. So those are the three basic research methods. There's certainly more detail explained in your textbook, but here you have some basic foundations to work with, and this allows us to, again, collect reliable information using the scientific method. The final thing I want to touch base on in this video is ethics. This semester, you're going to be reading about and watching videos about a ton of different psychology studies that are questionably unethical. That's the thing about research on humans, is that sometimes researchers put participants in situations that are potentially unethical. And the same thing with animals. For example, sometimes animals are put in situations where they might experience pain in order for us to learn about the effects that are related there. So importantly, today we have ethics boards that always make sure that the benefits of research outweigh the risks. But that's a consideration that you need to be making as we go forward, because some research situations are, they're questionable, and you might disagree with, the idea that the benefits outweigh the risks, and that's something that you should be discussing with us during this semester. Is you might say, that study seemed really unethical. I'm surprised that it was conducted. And that's something that I want to be exploring with you this semester is, is the research that we conduct in psychology, is it is it important that we learn about human thought and behavior, even if it means putting people at risk. So in your textbook, review the following concepts: informed consent and debrief. And you'll look at how researchers actually have to interact with their participants in a way to make sure that they are protected. The problem, I think, is that animals cannot, they can't voice their opinion. So humans are much more capable of saying, you know what, no, I don't want to be involved in this research. I'm not willing to be exposed to the risks involved. Unfortunately, animals cannot, say no. So again, that's another tricky situation that psychologists are faced with, is we want to solve problems. We want to learn about humans. We want to improve human life and increase happiness and well-being. But sometimes that means studying people and animals in a way that potentially is problematic. But nevertheless, we have ethics boards that are fully aware of the idea that the risks are there and the benefits have to be outweighing those risks. All right, so I think I've stumbled upon my words enough at the end here, but importantly, just in review, the scientific method, it's a critical element of psychology, and these three basic research methods are going to be explored all semester. And so right now, make sure you have a basic understanding of each one and the differences among them. All right, I will see you in the next video.